guys, we've talked a little bit about how the periodic table here works, how it's set up, what the qualities are, how we have solids over here, non-metals here, the metalloids along the stair step here. So you've gotten a feel for some of that, and then of course a lot of the vocabulary stuff about how the metals are malleable, ductile, conductive, flexible, all those kind of things. But there's some stuff about the periodic table that I wanted to show you that is just amazing. The more I learn about this tool, the more amazed I am at what Mendeleev and Moseley were able to create. So here's what I want you to do. I want you to write this in your notes, okay? So I'm going to just draw kind of a quick sketch of the periodic table. You know, it's got the single, small, or a smaller section here, not single, but a smaller section here. So I'm going to draw that smaller section. And I come across, and I've got this bigger section here. Kind of a castle-like look to it, right? I mean, that's the periodic table. So I want you to draw something like that in your notebook. And it's okay if you get a little more simplistic, you know, if you just draw it with a rectangle with horns on it or something along those lines. But then these are the key ideas that I want you to get. So as we move from this side of the periodic table across this way, something is happening here. So I'm going to draw myself an arrow that gets bigger as I go this way. See how I'm going to draw that. And this is number of electrons. So as we move across the periodic table this way, the number of electrons increases. Hydrogen has 1 electron, 1 proton. Helium has 2. It tells us up here in this corner, right? If the atomic number is 2, it has 2 protons, and every element that's stable has the same number of electrons, so it would have 2 electrons as well. All right, so the number of electrons increases as we move our way across here. The opposite is happening if I go this way. Let me make that a little bit smaller to start with. Is that how I want to do that? No. I'm going to start with a wide arrow here, and I'm going to get smaller. And this is reactivity. Reactivity is the tendency of an element to bond with something else or to have some kind of an interaction with another element. And we know from our earlier work that these metals here, the alkali metals, are extremely reactive. I like to talk about sodium a lot. That's the Na on the periodic table. I use that as an example a lot of times because sodium is so cool. If it's a metal, and if you drop it in a cup of water, it'll just blow all the water out of the cup. So that, I find that really cool. I think it's pretty exciting kind of stuff about chemistry. And then the fact that we eat it, you know, I mean, sodium chloride, table salt, is this highly volatile reactive metal mixed with chloride, which is a really toxic gas. But we put it together and we eat it all the time. I mean, it's essential for our lives even. So that's pretty wild. So as you move across the periodic table, this way the number of electrons goes up, but reactivity goes down. So the noble gases over here on this end don't really react much at all. It is possible that they can react, but it takes a lot of pushing them to get them to react. In normal instances, they don't react, which is why we call them noble gases. Nobility, like royalty, they're kind of above the fray. All of these other elements are doing all of this sharing of electrons, they're giving away electrons, they're taking electrons, or they're sharing them together and both of them holding the electrons. All of this stuff going on all the time. And these guys are above all that. They don't get involved in any of that stuff. So they're noble gases. And that's because their valence electrons are full. They all have 8 electrons. As we've moved across here, you know, this is the end here, we get to 8 electrons and they're completely full. So they don't need anybody else's electrons, and they don't have so many that they need to get rid of any. So they're noble. They're perfect just the way they are and don't need to be bothered with anybody else. All right, so what else can we do with this periodic table here where we can look at these kind of qualities of the table? That's the word I guess I'm going after here. So again, I'm going to draw another arrow. I'm going to start fairly small, and I'm going to get big as I move down here. And this is mass. So the mass of an element increases as you move down in this way. So the mass of helium is much, much smaller than the mass of radon down here. All right, and you can see that. Here's the mass of helium. It's 4. That's the number of protons plus the number of neutrons, so it has 2 of each. So it's 4. The mass of radon here is 222. So you can see this is much more massive. And remember, massive is not large, it is dense, it's heavy. All right, so that's mass going that way. And then also we have, I'm going to draw this one the same way. So this might be a little bit confusing. Don't get caught on this. And this is number of the number of electron rings. I'm using this abbreviation for electrons again. It's the E for electron with a negative symbol next to it. So it's an abbreviation for electron that I use a lot. All right, so while mass is increasing as we move our way down through the table here, the other thing that is increasing is the number of rings that the electrons have. So row 1 has 1 ring. So the valence electrons are the only electrons that there are. Row 2 has 2 rings, 3 rings, 4 rings, 5 rings, 6 rings, 7 rings. We don't know of any atoms that have more than 7 rings of electrons. And now these can be filled, they can have 118 electrons in them, but that's going out. Remember we talked about this earlier, that the innermost energy shell has only 2 electrons, it's the max it can hold. When you go up to the second level, the max it can hold is 8. Go to the third, I think it was 18, and then it carries on and carries on. So it's possible, I don't know this, but just looking at the chart, it's possible that the next row is 36, then 54, then 86, then 118, because that is where these stable elements have for their electrons. So it's very possible that that's what the rings are. I don't know that for a fact, but that would be my hypothesis. There's a science word that you guys are using more and more, and I'll have to check into that and see if that works. So anyway, I thought this was a really cool thing. Mr. Steele had showed this to me. He's a chemistry major, so he's a good guy to ask stuff about this. And it just helped me understand the periodic table so much more. So it's cool information. I'm gonna add one last thing. So we've got mass increasing here. I'm gonna go ahead and put a plus here just to make sure we know it's increasing. The arrow should show us that, but I'm just gonna make sure that we have that. Increasing, radioactivity decreasing. All right, and then one last thing as we go this way, start small and get big. And this is also mass increasing as we go this way as well. So as we move down, the mass is increasing, and as we move over, the mass is increasing. Now that means, like over here, hydrogen is less massive than helium, but helium is less massive than, say, xenon. So as we come across, it's getting more massive, but then it's almost like when we read, you know, we come across the row, and we start over here, we keep coming across. So helium has a mass of 4, lithium is 6.9, so it's more massive, and then we're gonna keep coming across. More and more massive, we're gonna come back here. This is more massive even than this. Even though it's on the right side, we've dropped down a row, so now that's more massive. So every time we go down a row and across a row, we're increasing the mass. All right, so that's our addition to the periodic table lecture. Thanks for joining us. Hope this helps you visualize more of what's going on, and just what an amazing tool this is that Henry Moseley really gave us as it is now, but Mendeleev had the vision to create it in the beginning. Thanks.
Yes.